Yeah, Maddie? Sure. What's up, dude? Thanks. Okay. So, I'm looking for something in this form. So right away I know that since the vertex is 4, -5, that my h and k are also 4, -5. And this other point here at -3, -2 is going to be like my xy. So if I plug those in, I can now solve for a. So I'll add 5 to both sides. And then -3 minus 4 is -7. The absolute value of -7 is +7, and a times 7 is just 7a. And then if I divide both sides by 7, I get 3/7. So we'd say y equals 3/7 x minus 4 minus 5. Is that okay? We're solving for a, is the goal. Amy? I'm a failure at life. Sydney? Sydney Meyer? What's your name? Hines. That's Sydney Myers. You guys did this on purpose, sitting right next to each other, didn't you? Because we took the absolute value, right? So it's -3 minus 4 is -7, but then the absolute value of -7 is +7, which should jive with what you see in the graph, right? If you look at the graph, it's not upside down, so it hasn't been reflected across the x-axis, so I know that the a value should be positive. Are you good with that? Mia?
I have 2 questions. One, so you said above, for absolute inequality, you said above if it's like the open side of the greater than equal to or greater than sign is pointing after.
So if the y is getting eaten, that's a greater than.
Yeah.
So that's a shade above if the y is being eaten by the alligator.
And then the other one is, you will only have extraneous solutions if there's more than one variable in the equation, right?
So you could get extraneous solutions if there's only one variable, if there's like a no solution situation.
Okay.
But you can't get like one working and one doesn't, unless there's variables in both inside and outside of the absolute value.
Okay.
You can still get one solution with one variable, but it would have to be like a 0 where you split and you get the same equation twice. You won't get a situation where one checks out and one doesn't, unless there's a variable on the inside of the absolute value and also on the outside.
Can you do number 4 on this worksheet?
Yeah, the ugly fraction one. What a bunch of wimps. Some friends, Gary. They're just inconvenient. It's okay. You guys can be wimps about it. Okay. So h is -3/5. K is cool. And then this guy is going to be like my xy. So -6/7 equals a times -10/9 plus 3/5 plus 7/3. So far, so good. Okay. So we're going to subtract 7/3 from both sides. But to subtract 7/3 from 6/7, we need to have a common denominator. The common denominator between 6/7 and 7/3 should be 21, right? So that's going to turn this into 49 over 21. I just multiplied the top and bottom of that fraction by 7 over 7. And this one is going to turn into then negative 18 over 21 by multiplying the top and bottom of that fraction by 3 and over 3. Everybody's okay there? So that's going to give us 31 over 21 is equal to, but then we need to add the fractions inside the absolute value as well. So negative 10/9 plus 3/5, well, we need a common denominator for that. Should be easy to see that common denominator would be 45. So I multiply 10 over 9 by 5 over 5. And I multiply 3 over 5 by 9 over 9. So that's going to give me negative 23 over 4. Yes, Mia?
Isn't it said that you're also subtracting 9 over 21 from 15?
Oh. Yep. Lovely. Yes, thank you. Okay, sorry about that. We're good still? Okay. So negative 50 over 45 plus 27 over 45 is negative 23 over 45. But we'll take the absolute value of that. So we get positive and then times A. Still good? Now we need to divide both sides by 23 over 45, but that seems silly to do. What should we do instead of dividing? Multiply by its reciprocal, right? That's a bit easier. And I would reduce as I go here. So for example, I notice 21 and 45 both contain a factor of 3. I'm sorry, that's not right. It should be 15. 23 is prime as well as 67, so there's nothing else I can do there. So I'm left just doing 15 times negative 67 and 23 times 7, as gross as that is, which comes out to be 161 at the denominator. I can do that in my head. 15 times 67, I could do in my head. I'm just not willing to think that hard right now about it. What it's like negative 670 plus 335. So that's like 1005 or something. Let's see if I did it right. Oops, that's too many 7s. Look at that. So just FYI, as a total aside, the way I did that in my head is I thought about 67. So this is easy to do. And then this is just going to be half of that, since 10 divided by 2 is 5. So that was how I was able to do it in my head. I didn't actually do the multiplication in my head the way it was set up. I found a short way to do it, or a clever way of doing it anyways. So that, I guess, is what our answer should be. Yuck. But the point of it was to illustrate to you the process didn't change, right? Inconvenient to deal with the fractions, tedious, easy to make a goof up, but certainly something we're capable of doing, right? We have to just be a little bit more careful about the fractions there. Joe?
I don't know if this is a tough question, but
No.
can you not use a division?
I mean, you could. I chose not to because I'm trying to show you how to remind you how to deal with the fractions again, which would be the only reason why you would ask a question about this problem in particular, right, is that the fractions were tedious to deal with and you wanted to review how to do the operations on fractions, which is why I chose not to use a calculator on this. Certainly you could. Is that okay? Okay. Tried to give you a real answer, not a silly answer. Because it wasn't a silly question. It's a real question. You know? Anyone else want to talk about any of these from the homeworks? Jane. Homework 2, number 1. Sure. Okay. So it asks me to first write down the values for A, H, and K. To do that, I'm just using this form to identify the values for A, H, and K. So I don't see any coefficient. So if there's no coefficient in we know that means it's 1, because if there's no multiplication, or if there's multiplication going on and we don't write down the number, it was a 1. I see no H being subtracted, so I know the H is 0. And then the plus 3 at the end tells me K is 3. So the only one of these that really is doing anything is this one. So that's the only one I'm going to bother to write down. I'll just write that it goes up 3. Okay? So then I'm going to do my transformation map, which in this case is just going to be y plus 3. Okay with that? So again, what I used there was, well, we don't have any of these. X plus H, A, Y. But that's really just X comma Y plus 3, right? So this one becomes negative 1, 4. That becomes 0, 3. And that becomes 1, 4. So negative 1, 4 is like right there. 0, 3 is there. And 1, 4 is there. So that's my graph. Does that feel okay, Jane?
Yeah.
Okay. Oh, yeah, we forgot to do that part, huh? Well, we know that for absolute value functions, the domain is always negative infinity, positive infinity. The range depends on 2 things. It depends on the sign of A. Since our A is positive, we know it's going to go from K to positive infinity. So for us, and we're done. Is that okay there?
Yeah.
If the A was negative, we would have gone from negative infinity up to K.
Okay, those are the only two.
Those are the only 2 possibilities for the range. It'll be one or the other. You're welcome. Joe?
So for A, for A, I put 0. I still have the right answer.
Well, if you really have gotten 3 for every coordinate, because this would have just simplified down to 3, because 0 times y should be 0. So I think yes, just got lucky. Ella. Homework 1, number 5. Certainly. You said 5? Okay. So the first thing we want to do is get the absolute value by itself, but that's already been done, right? There's nothing added or multiplied to it. So we're ready to split. So one split, I just remove the absolute values. And the other split, we remove the absolute values and we negate the right-hand side. So for the first one, if I subtract 5, I'm left with negative x equals 2. And if I divide by negative 1, I have x equals negative 2. On the other equation, I'll subtract 5. That'll give me negative x is equal to negative 12. And divide by negative 1 gives me x equals 12. But I'm not done. I need to make sure I check. So if I plug negative 2 back into this, I'll have 5 plus 2, which is 7. So that should work. If I plug 12 in, I have 5 minus 12, which is negative 7. And the absolute value of that is positive 7. So that one works as well. So I should keep both of these answers. Is that okay? And again, when you guys are on the quiz or the test or whatever, you don't need to write down the checks, but you need to make sure that if you're keeping an answer, you box it, and if you're discarding an answer, you put an X through it or something to cross it out. Sydney.
Can you do 25?
Sure. So do you want to do 25 the quick way or the not quick way? Do you have a preference? Okay. Well, I'm going to do it the easiest way because I don't even have to do any solving to do this. So remember, what kind of numbers can an absolute value give you? Close. Non-negative, right? You can get 0 back out of an absolute value also. Are you okay with that? So here we have the absolute value is greater than 0. There's only one number then that we can't have that absolute value take, which is 0. What value of x is going to make that absolute value 0? None. So this is basically, or what you would have ended up writing was, oh, probably not like intervals. Probably you would have written x is less than 9 or x is greater than 9. Had you tried to solve that algebraically? Should we see it algebraically? That's fine to say yes, if you're unsatisfied with my explanation before. There's no problem. Again, in a stressful situation, it's unlikely you'd slow down to think about it that way. So we're ready to split because there's nothing else going on to the absolute value. So one, we just drop the absolute value, and the second, we negate the right-hand side, but we also have to flip the inequality when we do that, right? So then we'll add 9 to both sides. So I have x is greater than 9, and then I have x is less than 9. And to tell if it's an and or an or, maybe we'll draw them this way. We can see that's the or situation. Is that okay? So either way of kind of thinking about that is fine. You could look at it and go, oh, an absolute value greater than 0, that's going to be all the answers except for where x is 0. So this answer, perfectly reasonable. Or you could interpret it as this. That's perfectly fine. Or you could have done it algebraically like we did there. Just kind of the standard approach. Is that okay? So that was a nice one where there's a couple of different ways you could kind of approach that. Any last questions here? Yes, Jane. From this same sheet? Sure. Now, how many of you looked at this straight away and thought no solution? Yeah. Not unfair to do that. What's the problem with treating this as no solution right away? Because of the x there, we don't know if x is positive or negative. If x is negative, then this is fine, right? So we still do need to solve this. We can't immediately say that this is no solution. Which is sneaky, but you know I'm a sneaky guy, so you shouldn't put that kind of stuff past me. So we'll break this into two equations. I'll subtract x from both sides. So here we get x equals -3. And here we get x equals +4. And then we need to check these. If I plug the -3 in, I get 21 equals 21. So that's good. If it's -28, that one's bad. So I should have just one solution there. Are you okay with that, Jane? So this is a good question because it's easy to look at this and think, no solution, it's negative. We're not sure that it's always negative, right? There's values for x where that would be positive. So we did need to solve that. Okay. For the rest of your time today, I'm just going to let you guys work on the review, or if you have other homework things, or if you have individual questions you want to have addressed, that's all. Any of that stuff is fine. But before we break off and do that, let's talk a little bit about what the test format's going to look like. So we have the test review that I've posted, and I have the key to go along with it, right? You guys have hopefully seen that on the content library. So the format for the test is basically going to be identical to the test review. The only difference is there might be fewer questions in some of these sections. So you'll have some solving absolute value equation problems. Yes, Joe?
You only phrase it the same way?
Yep, the directions will be identical. So you'll have some solving absolute value equation problems. You'll have some solving absolute value inequality problems. You'll have some graphing absolute value functions where I ask you to do the same stuff. So it'll be format, look like the question format will look identical, like it'll have the same blanks that I ask you to fill in. Some absolute value, graphing absolute value inequalities in two variables, like this one. Again, the same exact format. And then some modeling questions, where again, these ones where I've given you the graph, you'll notice that I've also labeled a point on there for you, or labeled the points. I know that it's sometimes difficult to track and find those, so I've gone ahead and done that to help you out. So that's going to be basically the test format. So you have those 4 kinds of questions. Nothing's going to be absurdly tricky, right? There's no weird theoretical stuff and not a lot of extra memorization past what you remembered from last chapter. So keeping in mind things that you might need that I won't give you. Okay. What's going on, Pen? Did you just die on me or something? Okay, so that apparently is deciding to act up on me. I wonder if it's everything. Yeah, it appears to us. Seems like it's everything. Okay. Well, we'll just do this verbally, since it's apparently not going to let me write anything down. So things that you would need. Well, you would need the general form for a transformation of an absolute value function, so you can identify the AH's and K's. Now, you don't actually have to remember the formula per se, but you have to be able to look at one of those absolute value functions and identify the AH and K from it. And you need the general form for when you're modeling to write the equation, right? Everybody's okay with that? So that's something you'll need to have memorized. You'll need to remember that. You'll need the transformation map that xy goes to x plus h, ay plus k, because I'm not going to give that to you. So if you're graphing and you need to transform those points, you need that. Is everybody okay with that? You'll need to remember the 3 key points for any absolute value graph: -1, +1, 0, 0, and 1, 1. Again, I'm not going to give you those. And you'd have to remember like the dashed and solid line and shade above or below rules for graphing the inequality. You won't get those. And then you'll need to know what A, H, and K do, like reflect across the x-axis or vertical stretch or shrink, left or right, up or down. You won't get that information. Is everybody okay with that, though? Again, most of this stuff is still recycled from Chapter 1, right? Where I told you in Chapter 1, like, you need to memorize some of this stuff, and some of it I gave you, but told you you wouldn't be getting it all the time, and this is where we're starting to pull back a little bit on it, but that's okay, because you've done it now for 2 chapters. Hopefully some of these things are kind of memorized by now, or won't take very much to rememorize it because you've done so many problems that involve using these formulas or forms that it's easy to remember now. Just as a heads up, looking at your homework, I graded homeworks here this morning, or looked at them this morning. Many of us, when we were graphing our absolute value functions, were getting straight lines. Should always get a V, okay? Regardless of what it is, it should always be a V. Looking at some of you, I think we used the point -1, -1 instead of -1, +1. So some of the people's error I could point out, and some of them I couldn't. But be careful about that, okay? Make sure that when we draw our absolute value graph, there's no reason to put a straight line on there. Okay, has to be a V. Joe. No problem. Ella. Yes, exactly. Yeah. So one of the things about these absolute value functions is every horizontal stretch or shrink can be described as a vertical stretch or shrink. So like if I stretch this way, the arms are just going to get wider. That's the same thing if I shrink vertically, right? It's going to cause the same effect. The arms are going to get wider. So rather than having both going on, we kind of factor that B out to the front, and it just mixes in with the A, and we can just describe everything vertically. And that's pretty common. X, because all we have is an A. Because if you think about it, if B is negative, you can take the absolute value of B and pull it out, and then the negative sign disappears. So all the reflections are going to be across the x-axis. If you think back to the original graph, if you reflect that across the y-axis, what do you get? The exact same thing, right? Because the V is like right at the origin. If you reflect it, it's just going to be the same exact graph. So even if you have it vertex located elsewhere, if you reflect it across the y-axis, I can describe the same thing with like a shift left. And that's what ends up happening when you factor the B out. The H just changes sign, and the B disappears, so that reflection across the Y just becomes a horizontal translation. So yeah, so everything that B does gets covered by one of the other transformations. We just don't need it for an absolute value. So it just makes everything a little bit simpler. Now, all that I explained to you is far beyond what I'd expect for you guys to go or to do. But that's kind of the why to that question. Okay with that? Yes, Jake. Yeah, no problem, man. Okay, so you guys have, I don't know, 40 minutes or something left here in class. Take the rest of the time, work on your review, or if you have other questions, you want to look through your homework and see if you had anything else individual you want to talk about. I'm happy to answer individual questions, so come on down or whatnot. And yeah.
Okay, so.
Hi, Jenny.
Hi. So for transformations, this would be X, right?
Yes, that is a mistake. Oh my.
Okay,
And my
I just
pen
wanted
doesn't
to make
even
sure.
work. Yeah. Let's fix that. This is what.
September 1st.
Yes, as long as I don't have to hear it. September 1st. Oh me, oh my. Thank you.
Yeah.
Thank you also for sharing your pen with me.
No problem.
I didn't really ask. I just took it. So
That's okay.
That's even better.
Okay.
Okay, so I did that. Let me resync. If you have that downloaded though into your own notebook, it won't.
Yeah.
It won't.
Okay, how do you sync your notebook?
Okay. So is this in the? You're looking at the content library. If you just right click on the notebooks.
Oh, and then you just
Sync status and just hit sync all.
Okay.
And it'll get them all.
Thank you.
Yeah, no problem, dude. Joe.
So, could this, do you have spectrum? Do you see how like,
It's vertical there?
yeah,
Yeah, that should not happen.
Yeah, okay.
Should never happen. Should always be a V, not like an angle or whatever.
That's
Yep. Good question. The "cannot this ever happen" questions are helpful because if you're looking at, your quiz or test answer and you see something like unusual, it's like, well, maybe that could happen. But no, what you've showed me cannot happen for an absolute value function. All right.